Our objective in this lesson is to illustrate direct variation. It is a relationship between two variables in which one is a constant multiple of the other. Also, as one variable, such as x, changes, the other variable, y, changes as well by the same factor, meaning x and y always have the same ratio. Given two quantities, x and y, an increase in x causes an increase in y as well. Similarly, a decrease in x causes a decrease in y. The increase or decrease must be of the same ratio. Here are some statements of direct variation. Y varies directly as x. Y varies proportionally as x. Y is directly proportional to x. Y is equal to kx is read as y varies directly as x or y is directly proportional to x. How about m is equal to kn? It is read as m varies directly as n or m is directly proportional to n. How about p is equal to kq? P varies directly as q or p is directly proportional to q. Let us create an equation on the following statements. Number 1, the revolution r of tires varies directly with the speed s. So we have r is equal to ks. Next, the volume v of a cube is directly proportional to the cube of its side. So we have v is equal to kc. Next, the cost c of buying rice varies directly with the number n of kilos you are purchasing. So we have c equals kn. Another one, for hourly paid jobs, the pay P for overtime work varies directly with the number of hours you extend. So we have P is equal to KH. Last one, the sales tax T of a product varies directly with its cost. So we have T is equal to KC. Here is the mathematical translation of direct variation. Y is equal to Kx, where K is not equal to 0. K is what we call constant of variation or proportionality constant. Remember that there is always just one term in the formula. The variable is multiplied by some constant. Determine if the equation is a direct variation. If it is, solve the constant of variation. Let's have the first example. 9y is equal to 5x. So let us solve for y. Let us divide both sides by 9. 9 and 9 will cancel out. So we have y is equal to 5 over 9x. Now this is a direct variation since I only have one term here. For the constant of variation, that is the numerical coefficient of the variable x. So k is equal to 5 over 9. Another example, 8x plus 2y is equal to 0. So let us solve for y. Let us move 8x on the other side. So we have 2y is equal to negative 8x. Now let us divide both sides by 2. 2 and 2 will cancel out. Negative 8 divided by 2 is negative 4. So y is equal to negative 4x. Once again, I only have one term here, so this is a direct variation. For the constant of variation, that is the numerical coefficient of the variable x. So k is equal to negative 4. Last one. 9x plus 3y is equal to 21. So let us move 9x on the other side. We have 3y is equal to negative 9x plus 21. And then we divide both sides by 3. So 3 and 3 will cancel out. Negative 9 divided by 3 is negative 3. 21 divided by 3 is 7. So we have y is equal to negative 3x plus 7. Now, we have two terms here. Therefore, this is not a direct variation. This time, let us solve for k and write the equation of the direct variation. Number 1, y is 63 and x is equal to 9. Let us recall the formula for direct variation. Y is equal to kx. To solve for k, let us divide both sides by x. So x and x will cancel out. So we have k is equal to y over x. Now let us substitute the values of y and x in this formula. And 63 divided by 9 is 7. So k is equal to 7. For the equation of the direct variation, again, we have y is equal to kx. This time, let us substitute 7 in our k. So we have y is equal to 7x. Another one, y is equal to 40 and x is equal to 6. Let us make use of the formula of k and substitute the values of y and x. Both numerator and denominator are divisible by 2, so we have 40 divided by 2 is 20 and 6 divided by 2 is 3. So k is equal to 20 over 3. For the equation, once again, y is equal to kx. Let us substitute 20 over 3 for k. So y is equal to 20 over 3 of x. Next one. Y is equal to 0.7 and x is equal to 0.4. Again, the formula for k, and then let us substitute the values and let us solve for k, and that is 7 over 4. For the equation, we have y is equal to kx. Let us substitute 7 over 4 in our k. So we have y is equal to 7 over 4 of x. I still have some space here. Let's have another one. Y is 600 when x is equal to negative 30. So once again, the formula for k. Then let us substitute our values here. 600 divided by negative 30 is negative 20. For the equation, y is equal to kx. Let us substitute negative 20 for k. So y is equal to negative 20x. What if the unknown is x or y? Example. Given that y varies directly with x and y is equal to 36 when x is equal to 9, find x when y is equal to 72. One good strategy in solving this kind of problem is to create a table. So I have here x and y. It says here y is equal to 36. So let us write 36 for y when x is equal to 9. So x is equal to 9. Find x, so x is unknown, when y is equal to 72. Let us recall the formula for k, and k is equal to y over x. Let us substitute the values of y and x in our formula and solve. 36 divided by 9 is equal to 4. Now, to solve for x, let us recall the formula of direct variation. We have here y is equal to 72 and our k is equal to 4. Let us substitute those to our equation. To solve for x, let us divide both sides by 4. So 4 and 4 will be cancelled out. So x is equal to 72 divided by 4. And that is equal to 18. So when y is 72, your x is equal to 18. Another example. Given that y varies directly with x and y is equal to 5 when x is 15, find y when x is negative 75. So again, let's create a table. So y is equal to 5. Let's write 5. When x is equal to 15, find y. So this time we're looking for y when x is negative 75. Let's have the formula for k and substitute these values to our formula. 5 over 15 in lowest term is 1/3. Now, to solve for y, let's have the formula for direct variation. Our k is 1/3 and our x is negative 75. So let's substitute. 1 times negative 75 is negative 75 divided by 3. Y is equal to negative 25. So when x is negative 75, your y is equal to negative 25. This time, let us write an equation when a point is given. Write an equation of direct variation that passes through the point negative 2, 8. Step 1. Start with the function form of the direct variation, and that is y is equal to kx. Step 2. Substitute x is equal to negative 2 and y is equal to 8 in this equation. So we have 8 is equal to k times negative 2. Step 3. Solve for k. To solve for k, let us divide both sides by negative 2. So negative 2 and negative 2 will cancel out. So we have k is equal to 8 divided by negative 2. And that is k is equal to negative 4. Next step, substitute the value of k in the original formula. So our k is negative 4. Substituting here, we have y is equal to negative 4x. Another example, write an equation of direct variation that passes through 7, 6. Again, step 1, let's start with y is equal to kx. Step 2, substitute x is equal to 7 and y is equal to 6 in the formula. Next, let us solve for k. So this time, let us divide both sides by 7. So 7 and 7 will cancel out, so k is equal to 6 over 7. Last step, substitute the value of k in our original formula. So y is equal to 6 over 7x. Now let us talk about graph of direct variation. Let us consider the equation y is equal to 2x. This is a direct variation because I only have one term here. Let's have a table of values. So I have here values of x and let us solve for the values of y. To do that, let us substitute the value of x in our equation. So we have y is equal to 2 times negative 3. So 2 times negative 3 is negative 6. Next, 2 times negative 2 is negative 4. Next, 2 times negative 1 is negative 2. Next, 2 times 1 is 2. 2 times 2 is 4. And 2 times 3 is 6. Now let us graph this one. So we have negative 3, negative 6. So we have negative 3 and then negative 6. Then we have negative 2 and negative 4. Negative 2, negative 4. Negative 1, negative 2. 1, 2, 2, 4, and 3, 6. Now let us connect the points. And this is the graph of a direct variation. And what can we say about the graph? The graph of a direct variation is a line graph. And what else? The graph passes through the point 0, 0 or the origin. Let us continue. Determine if the graph is a direct variation. Let's have the first one. So it is a line graph and it passes through the origin. Therefore, it is a direct variation. Next one. It is a line graph and it passes through the origin, so it is a direct variation. Another one, it is a line graph but it does not pass through the origin, therefore it is not a direct variation. This time, let us talk about table of values of direct variation. Determine if the table of values is a direct variation. If it is, solve the constant of variation. Let's have the first table. To determine whether the table of values is a direct variation, we have to solve for the value of k on each pair. So again, the formula of k is y over x. So let us solve the k for the first pair. Our y is 10, our x is 2, so this is 10 over 2 and this is equal to 5. Now for the next pair, we have 20 and 4, so 20 over 4 is also equal to 5. Third pair, we have 30 and 6, and 30 divided by 6 is also equal to 5. Since the constant of variation is the same for all pairs, then this table is a direct variation. Another example. Let's solve for the value of k. So we have negative 4.2 divided by negative 2 and that is equal to 2.1. Next one, negative 2.1 divided by negative 1 is also 2.1. For 0 over 0, remember the graph of a direct variation, it passes through the origin. So let's not get any more the k of that. Next, we have 4.2 and 2. So 4.2 divided by 2 is also 2.1. Since the constant of variation remains the same for all pairs, then this is a direct variation. Another example. So we have negative 6.2 divided by 2 and that is negative 3.1. The second pair, negative 12.4 divided by 4 is also negative 3.1. Third pair, negative 21.5 divided by 7 is negative 3.07. And it is not equal to negative 3.1. We do not consider rounding off. Therefore, this is not a direct variation. This is it, application of direct variation. Ernesto earns 50 pesos an hour at Save Mart store. Write a direct variation equation to describe this situation and determine how much he earns for working 14 hours. So we have here 50 pesos an hour. So meaning this is constant. So this will be our K. Next, let y be equal to the money earned. And we are asked to determine how much he earned. So this is what we are asked to solve. Next, let x be the number of work hours. And here, it is stated that this is equal to 14. Remember the formula? Y is equal to kx. So let us substitute. So y is equal to 50 times 14. And this is equal to 700. Therefore, Ernesto will earn 700 pesos for working 14 hours. Another example, Sydney enjoys making graham balls. For 1½ cups of crushed grahams, he makes 20 graham balls. How many graham balls can he make with 6 cups of crushed grahams? So we let x be equal to the amount of crushed grahams, and that is 1½ And then we let y be equal to the number of graham balls, and that is for 1½ 20 pieces. Now we are asked to determine how many graham balls. So we are asked to solve for y sub 2. Can he make with 6 cups of crushed graham? So 6 is our x sub 2. Remember the formula, y is equal to kx. So let us now substitute these values in this formula. Our y is 20, our x is 1½ or 1.5. Solving for k, let us divide both sides by 1.5. So 1.5 will be cancelled out. K is equal to 20 divided by 1.5, and this is equal to 13.33. Now, let us solve for the value of y sub 2. So once again, y is equal to kx. This time, our k is 13.33 and our x is equal to 6. Let's substitute. 13.33 times 6 is 79.98. Round off, y is equal to 80. So the last piece is a little bit smaller than the first 79 pieces. Therefore, Sydney can make 80 graham balls. Another one. The circumference of a circle is directly proportional to its diameter. If the circumference of a circle with 12 inches diameter is 37.70 inches, what is the diameter of the circle whose circumference is 78.5 inches? So first, let us create the equation of the direct variation. It says here the circumference is directly proportional to its diameter. So C is equal to KD. Next, the circumference is 37.70 if the diameter is 12 inches. Next, what is the diameter? So we are asked to solve for D sub 2, whose circumference is 78.5. So C sub 2 is 78.5. So our formula is C equals KD. Let us substitute these values here. Our C is 37.70 and our D is 12. To solve for K, let us divide both sides by 12. So 12 and 12 will be cancelled out. K is equal to 37.70 divided by 12, and that is equal to 3.14. Now let us solve for D sub 2. Again, C is equal to KD. Our C is 78.5 and our K is 3.14. Let us divide both sides by 3.14. So D is equal to 78.5 over 3.14, 25 inches. So the diameter of the circle whose circumference is 78.5 is 25 inches. Quick tips. The equation of direct variation is y equals kx. The graph of direct variation is a straight line and it passes through the origin. Given a table of values, the constant of variation is the same for all pairs of x and y. Now it is time to check your understanding. Pause this video for more time. Let us answer. So price is directly proportional to its area. So P is equal to KA. Next, 700,000 pesos. So that is our price for 200 square meters. So 200 is our A. So let's substitute those values. Let us solve for K. Let us divide both sides by 200. 200 will be cancelled out. K is equal to 700,000 divided by 200, and that is 3,500. Now let us solve for P if the area is 500 square meters. So our P is unknown, our K is 3,500, and our area is 500. So 3,500 times 500 is 1,750,000. Therefore, a 500 square meter lot will cost 1,750,000 pesos. Gets?